Okay, so the next chapter that we're going to cover is chapter 4, which is called Types of Chemical Reactions in Solution Stoichiometry. So the first thing that we should talk about are what are solutions. So there are two different components to a solution. There is the solute and the solvent. So the solute is the substance that's dissolved in a liquid to form a solution. So the solute is whatever is dissolved in the solvent. The solvent is the dissolving medium. So if you were to add salt to a glass of water and dissolve it, the salt is the solute because it's what's being dissolved, and the water is the solvent. Okay? So that's one example. So water is really the common solvent. It's used a lot as long as the substance can be dissolved in it. So aqueous solutions are how we refer to solutions in which water is the solvent. So if you ever see a compound written like this, that means that that compound is dissolved in water and it's a solution. So this NaCl is what we talked about here. It's a saltwater solution. So water can dissolve many different substances. And the way that water dissolves these substances is because of some of its properties. So water is a polar molecule. Polar meaning it has unequal charge distribution. So that means there are partial charges, so that's positive or negative, on the atoms in a water molecule. Okay, so this image over here shows the partial charges. So these are always represented by a delta symbol. So delta spelled out in words, but it's this squiggly, kind of looks like a D. But you can see that oxygen has two partial negative charges, and each hydrogen has a partial positive charge. So these charges are unequal, which makes water a polar molecule. Water's polarity contributes to its ability to dissolve so many different compounds. So what happens when you put salt in water is that the positive ends of the water molecule, so the hydrogens, attract the negatively charged anions. So in salt, we have sodium, which is plus, and chlorine, which is minus. So remember your charges. Halogens always have a -1 charge, and sodium is in the 1A group, so group 1A. So chlorine is a halogen, sodium is in group 1A. So they will always have, sodium will always have a +1 charge and chlorine will always have a -1 charge. So the positive end of the water molecule is attracted to the negative chlorine. The negative ends of the water molecule are attracted to the positively charged cations. So in this example, the salt, the negative ends are attracted to the sodium ions. So this whole process is called hydration. Hydration of a compound causes it to fall apart. So that means that the ionic substances break up into their individual cations and anions. So if we were to write this out for the example we did here, if we have sodium chloride, we started with a solid, and then we're going to add H2O, or water, which is liquid. Then what's going to happen is that compound is going to break up into its component cations and anions. So it's going to have sodium, which is +1, and that's now aqueous, plus chlorine, which is -1, and that's also aqueous. Okay, so another example is from your textbook. They have an ammonium nitrate compound, which is a solid, and then they add water or put it in water, dissolve it, and that breaks up into the component polyatomic anions. So ammonium, which is plus, and nitrate, which is minus. Okay, this little YouTube video actually shows the process. So there's no actual audio on this, and I'll post the link in Moodle. So just watch how the molecule interacts with the water. The sodium chloride molecules interact with the water. So that big thing on the right side is the sodium chloride. So now it's showing you the positive end and the negative end. And the distribution of charges on the sodium chloride. So again, like we talked about here, the water molecules are going to be attracted to the cations and anions. So the positive end of the water molecule are attracted to the chlorine atoms. The negative ends of the water molecule are attracted to the sodium ions. Okay, the overall message for this section is that there's two different components of a solution, the solute and the solvent. So remember, the solute is what's being dissolved, and the solvent is the dissolving medium. Water is a common solvent, and you need to understand how water actually dissolves ionic compounds, just like we showed in that example.